Hello and welcome back to Cracking the Cryptic, and currently on Patreon we have Tennis Anyone as our Sudoku hunt for the month, and Olimar sent us a puzzle based on table tennis to feature whilst that is still live. So you've still got a few days left to enter Tennis Anyone. Check it out on Patreon. Do join us on Patreon if you haven't already, but this hunt by Philip Bloomer, also known as Glum Hippo, and us, is rather excellent and has a fabulous meta to finish with. Just as I've started this video, the occasional hazard of a loud argument in Japanese is coming from my window. I hope you can't hear that. That is the penalty for occasionally doing a late evening video. I live in a block of flats which on every side border lots of other flats. We have nearby dogs, helicopters, neighbours who play music and sing, and indeed have evening shouting conversations in Japanese. Right, well, let's hope you can't hear much of that, and we will have a look in a moment at Table Tennis Timeout by Olimar. Now, before that, don't forget all our apps are available on the links under the video. And they feature domino apps which have Kropki dots and thermo apps which have thermos, and they will one day feature a line app which has renbands and equal sum lines and things in it. So check them all out. And there's also Sven SUDOKU PAD, our merchandise, the catalogue of our videos, the Discord server, loads of stuff under the video. We love it when you engage with the community generally, and please do let yourself have some fun with Sudoku. So, what are the rules today? Normal Sudoku rules apply. We're going to put 1 to 9 in every row, column, and 3 by 3 box. Along thermos, digits increase from the bulb to the tip, but we've only got 2 tiny thermos. Oh, by the way, let us recognise, first of all, this fantastic diagram of a table tennis table. Now, I've had to slightly shift the central green line so that we can see that there's a green line between those cells and a blue line between those ones as well. But you appreciate what you're seeing here is a table tennis table, 2 paddles or bats, and 1 white ball. I don't know what this is off to the side, probably footprints and where people have to stand. Anyway, it's brilliant. It's a brilliant idea. So we got to the thermos, digits increase from the bulb to the tip. Adjacent digits on a green line must differ by at least 5. This is normal German whispers. A purple line, normal renban, contains a set of consecutive numbers in any order. The digit sum on a blue line is the same in every box. So those 2 add up to whatever those 3 add up to, which is the same as whatever those 2 add up to. A black dot joins digits with a 1 to 2 ratio, and a white dot joins consecutive digits. There we go. Normal rules if you are familiar with the stuff that we do. Do give it a try on the first link under the video. My time will give you a bit of a guide as to how hard it is, but I'm going to restart my clock and say, let's get cracking. So, where do we go? I think we go around the table on the German whispers. Right, I'm going to tell you 3 things about German whispers. One is that 5 can never appear on a German whisper line because there is no Sudoku digit it can neighbour. The second is that therefore the digits must alternate between high, higher than 5, and low, lower than 5. And thirdly, 4 and 6, which we call monogamous digits, can only have 1 possible partner. 4 can only be next to 9, and 6 can only be next to 1. So there are quite a few cells where the 2 partners on either side of a line, or at least 2 partners, see each other. Okay, so the 5 thing's quite interesting. In these 2 columns, 5 is not on the green line, so it must be at one end of the column or the other. And that gives us a big old X-wing on 5 straight away. And that means we've used up the 2 5s in columns 3 and 7 in 2 of these 4 cells. And therefore, we've used up the 2 5s for row 1 and 9 in the same cells, and none of these cells can contain a 5, and that's actually slightly important. In boxes 2 and 8, if those can't contain a 5, we know green can't, so there must be a 5 in one of those cells. And in box 8 must be a 5 in one of those cells. Because these can't, because one of these definitely does. That's quite strange. This purple line will definitely have a 5 on it as well. Because any sequence of 5 digits that are consecutive, that use Sudoku numbers, either runs up to 5 or down to 5. So there's always a 5 on any 5-cell sequence. Now that's a lot about 5s. Okay, the other thing is that I'm going to colour this in alternating cells because of what I said about high digits and low digits. I'm going to use green and purple, which is a bit counterintuitive in a puzzle with green and purple lines, but it's because I want to eventually establish blue as low and orange as high, and I need to use contrasting colours until I find out which is low and which is high. It's interesting straight away. Okay, in these columns, there are 4 purples and 3 greens. So these ones outside are a 5. Oh, and the 3 greens, this is even better. The 3 greens are not monogamous because they each have 2 partners in the column that see each other. So none of those can be 4 or 6. So one of these 2 cells is green and is a 4 or a 6, and the other one is a 5. And the same is true here for purple. No, for green again. For green again. So these are actually a pair of the same 2 digits, 2 pairs of the same 2 digits. But I don't know whether they include a 4 or a 6 yet. But that digit will appear here and here. I don't know how to pencil mark this, because it can't be in any of those 3 cells, because they can all not be monogamous cells. In fact, the only cells on this whole green line that can be monogamous, I think, are these ones. Because they can, if that was a 6, it could have 1s in those positions. But there's nowhere else you could put a 6 or a 4. Now what is high and what is low, and how the heck am I meant to know? Maybe by this line. Yes, let's think about this line, this blue line. These 3, it's got 3 segments that are all equal. Now, I'm going to share another secret with you, and this is a big secret about every Sudoku. Every row, column and box of a Sudoku always adds up to the same number, and I'm going to share the number with you, 45. So that's because 1 to 9 add up to 45 all the time. So this row adds up to 45. Now, what do the 3 blue segments add up to? They must be less than 15. If they added up to 15 each, that would already be 45. You'd have to put digits in those cells, and that would break this new learnt fact. So it's less than 15, but there's going to be a lower limit as well. Let's say they were 9s. That would be 27. That is the lower limit. They can't be 9s either. 9 there plus 9 there plus 9 there would be 27. These 2 would add up to 18, which would be only doable by 2 9s, which is illegal. So the blue line sum that it is equal is somewhere between 10 and 14. Now, these are either 2 low digits, or 2 bother. No, not bother. Yes, bother. If they were 2 low digits, I think they could be 1 and 2, and that could be a 7. And if these were 2 high digits, they could be 6 and 7, and that could be, they can't be 6 and 7. Neither of these can be a 6 because of the monogamous rule. If these were high, if purple was high, these would be at least 7 and 8, and that would break this total, which can't be more than 14. So purple is low. We've done it. We're going to make purple blue. We're going to make green orange. And orange, what's gone on there? Orange is high. Can't get my colouring right. Orange is high. Blue is low. Oh, I came up with 1 plus 7 plus 2 to keep this down to 10. But that's not what although 10 is a possibility, I should have just been keeping this down to 14. If that was a 1 and a 2, this could be 7, 8 or 9. If this was a 1 and a 3, well, this would then have to be 8 or 9, making 12 or 13. Well, I don't know. I don't know what to do with it, this information, actually. Right, these are low. All of these numbers can't be 4. They're all 1, 2 or 3. Now, maybe it's... Oh, also, 1, 2, 3 and 4 appear on those blue cells. So these are a 5 and 6 pair. So are those. 4 is definitely in one of these cells. Well, it's in 2 of these cells because it has to appear in both column 3 and 7. So there's another weird X-wing on 4s. They're either in those 2 or in those 2. Now, these orange cells, not one of them can be a 6. These are all 7, 8 and 9. That's how we know this is a 5, 6 pair, I suppose. Just going to take out the corner marks now, which aren't doing anything. 6 has to be in one of those cells. 6 has to be in one of these cells. 2, 3, 4. This Renban can't have... Well, there are 2 low digits that don't get on it. I suppose it could be 5, 6, 7, 8, 9. But it could also be 3, 4, 5, 6, 7 at the moment, as far as I can see. I don't think I can... Oh, look, this is on... And this, they're both on the ends of a thermo. These tiny thermos are relevant. Those are now a 2, 3 pair. That's interesting. Those are either both 1s, or one is a 1 and the other is a 2. Oh, they're not both 1s for a lovely reason. If they were both 1s, the one in column 5 would be in this box on this Renban, and it can't be because 2 and 3 can't be on the Renban, so 1 can't be on it. In fact, now 2 and 3 can't be on the Renban. We're selecting from 4, 5, 6, 7, 8, 9. 5, 6, 7, 8 must all be on it. And 2, 3 are here. 5, 6, 7, 8 are on it. So these at the ends of the column are from 1, 4 or 9. And one of them is definitely a 1. Oh, and that's interesting. One of them is definitely a 1, and it is going to make the paddle digit a 2. So this is a 1, 2 pair. Which would, well, that is slightly interesting because that 1, 2 pair that I've got highlighted sees all of those cells and all of those, which now cannot have a 1 or a 2 in. I don't know what to do with that information, but it's true. Now I'm going to think about the fact that one of these has to be a 4. And that is going to have a pair of 9s appearing either here or here. And that means one of these is a 9. And that means this isn't, and it also means this isn't. But this not being a 9 is important, because I think the same's true down here. One of these is a 4, so one of these pairs includes a 9. i.e. one of these cells is a 9 and that isn't. Now the 9 in the column is in this group, which is 5, 6, 7, 8, 9. Which I say as though it's a thrilling discovery that's going to take me forward. I don't think it is, but it is nonetheless a true thing. So in this row, 4 and 9 are definitely going to appear either there or there. Does that do anything to the Renban? Not really. Not clearly. I don't know which. Ah, okay. If this was 7, if this was a 7, this would be 7, 1, 2 by the whisper rule. These would be 8 and 9, but by the equal sum line rule, these would have to try and be 1 and 2 to make up the 10 sums, which can't happen if we've put 1 and 2 there. So that is not 7. Now, if this is 8, that gives a lot more freedom to these things, but on the other hand, these would become 7 and 9. Eight, 2, 1 would be 11, and that would be no good because that would go with 7, 4 and 9, 2, and that would cause a clash of 2s. 8, 1, 3 would be 12, but that would need a 9, 3. That doesn't work either. 8, 2, 3 would be 13, and that does work. They would go with 9, 4 and 7, 6. So 8, 2, 3 is a possibility. What about 9? 9, 1, 2 is 12. Oh, bother, that does work with a 7, 8 pair. 9, 1, 3 is 13. That seems to work too. Oh, thought I was going to get something out of that. Didn't. Right. One of these two is a 2. And that means one of these is a 1. And in the other of these boxes, one of these is a 1. So the only places 1 can be in these boxes is in one of those 2 cells in each box. And 2s, it's the same. One of these is a 2. And one of these is a 2. And that's going to account for the 2 2s in those boxes. And one of them's up the middle and one of them's in a side. That didn't really do anything. Oh, there's one of these is 4, 9. Ah, that's huge. I'd looked at one of these being 4, 9, but actually one of these two is 4, 9, and that means this is never 9. And the same is true over this side. That's never 9. That's now a 7, 8 pair. So this is 9 in the middle. None of those can be a 9 now. Now, these are 7. Right, let's do this again. 9, 1, 2 is 12. That would go with 7, 5 and 8, 4, and you'd have 3 and 6 on the outside. 9, 1, 3 is 13, which would go with 8, 5 and 7, 6. You'd have 4 and 2 on the outside. 9, 3, 2 is 14, and then 7 wouldn't work. So it can't be 9, 3, 2. So one of these blues is a 1. Didn't really do anything. Yeah, there's either a pair of 9s there and a pair of 9s there, or a pair of 9s there and a pair of 9s there. What does that do? We got this 7, 8 pair. Is that doing any more? Whichever one of them is a 7, whichever one of them is a 7 has to be flanked by 1, 2. So in one case, this is a 3, 4 pair. And in one case, this is a 3, 4 pair. So in one case, in the top, in row 2 or row 8, you've got a 3 and a 4. In at least one case, could be both. But you've got a 3 and a 4. Going with an 8 and a 9 and a 2 here, and in that case you'll have a 1 here. I'm only just understanding now that the symmetry in this puzzle is amazing. It is literally only broken up by the ping pong ball. That's so mental. Oh, this puzzle is mad. Oh, right. No, hang on. I was going to say one of these is a 4. That's not true. Either both of these are a 4 or neither. Now, if this was a 4, Remember, you've got 9 here and either 7 or 8 here. What goes on the purple renban in the corners? Now, I don't know is the answer. I don't know if it helps to know, if you see what I mean. No, I don't know what's going on there. Okay, let's think about this central renban again, the 9, 5, 6, 7, 8 one. In one case, there's a 3 in these cells, which is flanked by an 8, 9 pair. And in the other case, because there's a 7 in one of these cells, we have a 3 in a corner of this table. So in one case, we have a 3 here and a 4 in one of those cells, and in the other case, we have a 3 and a 4 in those cells. And I think that means none of these can ever be 7. They have to be an 8, 9 set. And that means neither of these are an 8. 8 is in one of these cells, definitely. Oh, come on, teach me something, puzzle. Now, it doesn't apply up these flanks. In one case, this is a 7 and is flanked by 1 and 2. But in the other case, it's an 8. And 7 must be in one of those cells and be flanked by 1 and 2. So, one of the corners is 1 or 2. I don't know what that does. 9, 10. These either add up to 12 or 13. So this pair is either taking us to 13 with 6 and 5 or to 12 with 5 and 4. So there's always a 5 in those. And these can't be 9, 8, 7, 1 or 5. So I think they're either a 2, 4 pair or a 3, 6 pair. Which sort of seems promising for the black dot, doesn't it? If you put 3 or 6... Oh, if you had a 3, 6 pair in those cells, neither of these could be 3, 6. Is that useful? Maybe not yet. Ah, this is crazy. I want to make progress. I don't know what to do. Oh, there's a 5 and a 6 in this group of cells, and that one is 1 or 2. Oh, use the pencil marking. So this is now a 5, 6 pair, and down here it's true again. That's 5, 6 as a pair, and this is 1 or 2. Oh, I am going to leave in the 1, 2 pencil marking because 1 is in one of those cells and 2 is in one of those. Sorry, there we go. But I should have done this as for 5, 6. So that's a 5, 6 pair up the centre. This is now a 7, 8 pair. What's this? This is a 9, 8, 7 triple. That is going to have to be 6. The big disambiguating number is our first digit in the grid, which is very clever, Olimar. I mean, it's not. We've got a 9 in the middle. It's our second digit in the grid. Never mind. That is a 7 and that is an 8. I don't know if this is actually going to do any disambiguating straight away, but it's going to be important in the long run. It doesn't really, because they don't connect up to these. Oh, crumbs. I don't know what it means. Oh, I do. This is a 5 and that's a 6. This is a 5 and that's a 6. That's Sudoku. 6, 5, 8, 9. 2 is in one of those. These are from 1, 3, 4, 7. But 1 is not in those cells. It could be in the group, but not in those because it's in one of these two. So these are from 3, 4, 7. I bet that's the same up here. It is. Those are from 3, 4, 7, 2. And they must include a 7. I don't know what that means. Oh, there's now there's been for ages a 5 or 6 here. So this Renban can't run through 5 and 6. It can't be 7, 8, 9, because that would be too many 7, 8, 9s in row 2. Could it be 8, 7, 6? That would be a 5. The 8 would have to be here. That would have to be 6. It could be 8, 7, 6. Now, what else can't it be? It can't be 7, 6, 5 or 6, 5, 4 because of this. Can it be 5, 4, 3? Then we would have, indeed, if it's low generally, we have 5 blue digits here. Well, no, we have 5 digits from 1 to 5. That's 1, 2, 3, 4, 5. If this is under 6. And then this is a 7, 6 pair. And that's a 5. Oh, this is so close to doing something. I don't know how I'm using the ping pong ball in this 6, 7 pair. Is it just because... I don't know. 5 is in one of these 2 cells. This is low, 1, 2, 3 or 4. Is it worth keeping colouring low digits? I doubt it. I don't think I'm going to... Oh, maybe. Let's bother. They're blue. And these are orange. Okay, I'm doing it. I don't know why, really. I just need to get a little bit more purchase. What's going on? 8, 9, 1, 2, 3, 4. So these can't be from 1, 2, 3 and 4. The same's true up here, because that would be too many. So this Renban is either 6, 7, 8 specifically, with an 8 here and a 7, 6 here. Same is true down here, 8 here and a 7, 6 here. In fact, we know the order because of the black dot. I nearly called it the Black Death there, which is unpleasant. Now, they can't be from 1, 2, 3, 4. So the only other possibility is 3, 4, 5, and that would be a 6. And if it's 3, 4, 5, one of these 2 is a 5. Ooh. And that is 3 or 4, forming a 1, 3, 4, 7 quad. Oh, this is weird. I don't know if this is actually going to help. So if that's 7 and 6, 5 is included here. But if it's from 3, 4, 5, this is a 7, 6 pair. Now, on this black dot, we can't have a 5. We've got 3, 4 or 6. Now, that can't be 3 because 6 is banned here. Now that, no, symmetry keeps working. That can't be a 3 either. So these are not 6s. No, hang on. They're not 3s. That's what I mean. They're not 3s. They are 4 or 6. This digit, by black dot rules, is 2, 8 or 3. Come on. Now, I haven't established, and I don't know if these are the same pairs. Do these, if this is an 8, 7, 6 Renban, does that mean this one is as well? I don't know. I certainly can't assume that because I don't even understand. I not only don't know if I know it, I don't know how I would know it if I know it. I mean, I know that doesn't make any sense. It doesn't even to me, frankly. What I've just said makes no sense to myself. So never mind. Right, if this is 8, is that interesting? Then this is a 7, 9 pair. One of them is a 7 flanked by 1 and 2. With an 8 here, 3, 9, 4. Oh, maybe I can knock out the possibility of 4s on these corners, because then these would both be 6, 7, 8 Ren bands. These would be 6s in both cases. These would be 3s. This would be a 2-4 pair. This is assuming 4s on these busy corners rather than the more empty corners. Now, what else does that do? It would put 9s in all of these positions. Oh no, it doesn't work. Oh, does it? If that was 9, 4, this is 6, 7, 8. That's a 5. Oh, that's 3 then. Oh, it does work. And then we've got a 1, 2 pair to fill the box with. I feel it's more likely to break with the 4s in these busy corners, but I don't see why or how. Oh, come on. I've got so much done, and yet I feel like I'm not halfway through yet. I really do. This is weird. No, it's good. It's simple. This I've got as 4 or 6, but I know there's a 4 in one of those two positions. So it's 6. Right, this is a 6, 7, 8 triple. It can't be 6, 5, 4 because it would break that. That's right. The same is true here. This is a 6, 7, 8 triple. We're away. These are 3s. Let's see if I am halfway through or better. Now, the important thing there is not removing 3s from there, or indeed putting 5s in here and 6s in here. Although if something pops out that I think is unimportant, I'm taking it. This is a 9. It sees 7 and 8 in the box, and that one. Now, this can't be a 9, and this can't be a 4. The same is true here. That can't be a 9. These corners, therefore, can't be 4s, because they're next to 7, 8 on the Whisper. And actually 4 is in the busy corner where I asserted it wouldn't be. 9 there, 8 here. I wanted to put 8 there, but I don't know. Now I don't know about these 7, 8 pairs. Wow, this is crazy. Now I do have that 1, 2 pair. That's a 1, 2 pair. These are from, oh, that is a naked 4, given that 1, 2 pair. 7, I have a feeling I'm going to be colouring 7s and 8s shortly. There's a 1, 2 pair. I've got 4, 7, 8 over this side as well. The symmetry is continuing, unabated. The table tennis ball hasn't done anything. Now, I was going to take 3 and 6 out of this. This is a 2, 4 pair. So these are a 5, 6 pair. And these pairs add up to 13. This has to add up to 13. There's no 2 in it. It is a 9, 1, 3 set. That becomes 2 or 4. These are from 2, 4, 5 now. Come on. At least disambiguate the paddles. Or not. Okay, this can't be a 3 because it must come between a 7 and an 8. And 3s can't touch 7s. Same is true there. One of these is a 3. 6, 7, 4, 9, 8. One of these is a 5. I'm going to take out the blue and orange colouring now. I just don't think it's doing anything, and I have a feeling I'm going to start wanting to colour something like 7s and 8s, or maybe 1s, 2s and 3s. I don't know, maybe I won't have to colour at all, but I don't know what's going on yet. 1s and 2s might be interesting. Yeah, okay, let's colour 1s and 2s in bright blue and yellow. Bright blue there. Now, neither of those are bright blue, so I don't know, maybe this just doesn't work because I can't get anywhere with that colouring. Oh no, that is a 1, 2 pair, so that does continue up the grid. I remember establishing that earlier. Blue, no, not blue, yellow there. Okay, so that is not yellow. Ooh, one of these is yellow or bright blue, but one of these is as well. That's weird. I don't know which is which still. I mean, like, I keep thinking I'm doing some disambiguation, and the puzzle remains ambiguous. One of these is a 2. I mean, this is crazy. Okay, let's half colour the possibles. This is not normally how we do this. That's possible, 1 or 2 coloured. So is that. One of these is blue. One of these 2 is yellow. This is madness. I feel like I'm going almost bonkers now. Now, what has that proved? One of these 2 is blue. And one of these 2 is yellow. And I can do the same sort of thing here. One of these 2 is blue. One of these 2 is yellow. This is a colour. Don't know what colour it is. I was going to say that was a 2. That will have to be a 1. But these could both... Okay, here's the deal. If that's a 2, that's not, and one of those is, and that's a 1. But if this is a 2, those aren't 2s, that is, and this is a 1. So either way, one of these 2 digits is a 1. And they both see some cells. They see all of these and all of these. None of these orange cells can be a 1, which is weird. So 1 in this row is in one of those cells. 1 in row 4 is in one of those. I bet it's both of these, but I don't know that. Oh, such a strange puzzle. 6 has to be in that group and that group. 5's definitely in this pair and this pair. Oh, I don't know. Should I have been colouring 7s and 8s? Is that what you're telling me? Let's do 7s and 8s in red and bright green. I don't know. Let's try it, see what happens. That's red. I don't think there's as much connectivity, although we've reached across the whole grid already. One of those is red and one is bright green. Same down here. Don't know which is which yet. Now, one each of those, red and bright green. I don't know why I'm doing this colouring now. 8 there, and 7 in one of those cells. It's just not doing it. Oh, one of these 2 is bright green. And red is in one of these 2. What's that telling me? Orange meant there's no 1 in them. Why hasn't this ping pong ball helped disambiguate things more? It really hasn't. Or if it has, it's in a subtle way and it's not communicating with me. 5, 8, 7, that can't be a 3. Let's take these tiny little wins. That doesn't really mean anything. 2 4 pair out here, one of which is coloured, yellow or blue. The other isn't. The other is a 4. I just don't know. Right. Maybe I need to focus on if red is 7, what goes wrong? Because if red is 7, both these positions are flanked by 1 and 2. Then you get 3s here and here. And does something go wrong with that? That would have to be a 3. Where have we actually got 3s in the grid? Just in those 2 positions so far. Oh, this wouldn't be a 3. That would be where the 3 was. Then we would get a 3 here. And then we'd have a little X-wing of 3s in the middle. So this was based on red being 7. Just going to flash these cells with a colour grey. Those are the positions of 3s if reds are 7s. If greens are 7s and flanked by 1 2s, then the 3s in the column, ooh, are in those positions. That's rather unexpected and I think rather unhelpful. So then we'd have 3s here. One of those 2 would be a 3. One of those 2 we know. One of these 2, and then an X-wing. I don't know what that does. It doesn't do anything for me. Okay, let's forget the grey flashing. That's no help. I was hoping to reach some sort of compromise of digits that would have to be 3 in either colour scheme. Did not happen, as you noticed. Did not happen. I've done all the black dots, I've done the white dots, I've done the Renban. I've got most of the whispers done. I've still got this, that's a 1-2 pair issue. So they're different. So my colouring on blue and yellow, that feels like the most interesting thing I've done. And it's not giving me any actual proof of anything. No. Yeah, one of these is blue or yellow. So only one of these is blue or yellow. Does that mean one of these is coloured? Because then the 5... Yeah, hang on. One of these is a 5. So in one of these 2 cases, 5 has to move to the outside. So one of those 2 is a 5. It's not solving anything. 1 2 3 5 down here, and that one can't be a 3. Now, what am I meant to find? It just doesn't make sense. One of these is not a 3. Is that not? I don't know. Either reds or greens have to be, well, yeah, if those are reds, these are both 3s. And that's going to fix that that is the 3 in the central column. So if that's a 7, this is 1 2 5. Then we have 3 9 here. The same would be true here. If that's a 7, we have 1 2 5 there and 3 9 here. What does that do? Puts 2 in that corner. Oh, look at these corners. That is a 1 2 pair. That is a 1 2 pair. And they're looking into these corners. What is that doing? It's a 1 2 pair. Right. This isn't. What can this not be? It can't be 4 7 8 or 6. It can't be 5 or 3. And it can't be a 1 2 pair. It's a 9 in the corner. Is that true up here as well? Can't be 4 7 8 6 5 or 3. And we now know it can't be a 1 2 pair. That's a 9. Is that 9 going to help at all? Puts a 9 in one of those cells. Puts a 9 in one of those. It's not going to do anything, is it? I can sense it. Now this can't be 1 or 2 either, because, and I could be wrong about this, because of this colouring of blue. No, that could be wrong. I can't remember why. I don't know, do they have to include blue? Yeah, this is either blue or a 3, isn't it? And this is either yellow or a 3. That's true. And if it's a 3, they include blue. But if that's blue and a 2, then that's a blue too. So no, that's not good enough. I was hoping to find that this couldn't be yellow or blue, but I don't think I've proved that at all. And in fact, I think this blue shading is... it's not safe. This blue shading is safe. That blue shading is not. And I suspect this yellow shading isn't by the same token. I think I did that because I thought it was symmetrical before. It is not safe because that could be yellow. Sorry, I mean, sorry if you've already written a comment about the error there. I haven't used it and I'm not going to, but it's interesting. Right, in this row, 1 and 5 are in those cells. So this is 2 or 3. Just that's all that's left in the box now. Same is true up here. 1 and 5 are in there. 2 or 3 is there. I want to say they're definitely different, but that might not be true. In fact, well, in one case there is a 3 here. When there isn't a 3 there, there's a 3 in one of these cells, and that must be 2. And in the other case, there's a 2 in the corner looking at this, and it must be 3. So that is a 2-3 pair. Probably doesn't. I don't think there's any cells they see in common. I still need to disambiguate. The table tennis ball never did it for me, just like, I mean, I thought it was doing it. It just didn't. It completely bamboozled me. 7 in this box has to be in one of those 2 cells. That is so uninteresting. Oh my lord, what on earth am I missing? Bobbins, bobbins, super bobbins. Okay. In this column, 8 and 7 are here. I'm thinking about 1, 2, 3 and 5. 3 of them are there. Oh, the 4th one is here, but that doesn't form a quad necessarily. I don't know. That 1-2 pair in the corners was so exciting when I found it, and it's done nothing for me. I mean, you could easily bifurcate to a solution here, but that would be horrible. So 3s are either here. Oh no, hang on. If green is a 3, these are not both 3s, because either green is a 7, in which case that can't be a 3, or red is a 7, in which case that can't be a 3. So this is this a 2-3 pair? That would do the business if that's right. Is this a pair, or can they both be 2s? No, if green was... no, they can't both be 2s, because if green was a 7... you couldn't get a 3 down here next to it. And if they were both 2s and red was a 7, alternatively, you couldn't get a 3 next to red here. These are a 2-3 pair, and they're both seeing that cell, which is a 1, and this one, which is a 1. I'm really hoping that does something, although I have a feeling it's not going to, because I haven't discovered it. It just doesn't reach very far, but come on, I'm desperate to find some information. 2-3 pair here. One of those, okay, let's get rid of orange because that's done its job. It was identifying not 1s. Now, one of these is coloured blue or yellow. Okay, either this is blue, if that is coloured, or this is yellow. This hasn't done anything, has it? It's just found a couple of 1s in the grid. Oh no, this is a 1-5 pair. And one of them is, well, one of them is a 1. So now one of those is yellow. Or is it yellow? No, one of them is coloured. That's not the same. It could be coloured blue. It could be coloured blue here or yellow here. And this could be yellow. I don't know. This is also a 1-5 pair. Let's do that as well. I'm scared about the colouring. When I was doing the half colouring, that was to indicate cells that could be coloured and what colour they would be if they were. Okay, come on. That's a 2-3 pair. Gosh, this is so complicated, Ollie. What on earth am I meant to do to finish this? One of these is a 3, going with an 8 in green or red. So, maybe the other way to look at it is either red's 7, in which case those have to be 2s, or green 7, in which case those have to be 2s. And all that's telling me is either yellow is 2 or blue is 2, which I knew. Now, if yellow was 2, this is it. It's that simple. Right, if yellow was 2, there's nowhere to put a 2 in the central box. That's it, isn't it? This would be the 2. If yellow was 2, this would be 2. Let me just prove this to myself. That would be 2. That would be 3. This would be 2. That would be 1. This would be 3. That would be 8. Yes, this would be 2. If yellow was 2, there's nowhere for 2 in the central box. So yellow is 1. There we go. Yellow is 1. These partly... Well, that's 1 and is full yellow. Actually, so is that. They're both full yellow. These, which don't have a 1 candidate in, are definitely not yellow. Now we can do some 2s. In the full blue, there. That's now a 4. This is a 2-5 pair. That's not doing anything somehow. But I must know, this is a 3. That's just, yeah, this is just Sudoku in a way. 2 there, 4 there. 3-7 pair here. That's a 2. That's a 3. Oh my goodness, the relief. I think this is the final breakthrough. I mean, you know, I've said it before and I've been wrong, but I think we've got it now. That's it. That's the 2. It must be there and there. The 2s. Look at them. Look at them. Skulking in the wrong colours. These are 2s and they're all finished. 1s must be finished. 1 there. 1 here. How are we doing for 1s? They're all done. 3s. Oh, almost no 3s done. How bizarre is that? That's become a 3. That's a 3. 3 has to be next to 8. Red is 8. Green is 7. Those 2 are 7. Okay. Let's get rid of all the colouring because I don't think it's adding anything now when we can do the numbers like 4 there. 5 and 8. I can do those. Wow, this puzzle. This puzzle. Table tennis is a real puzzle today. Now, that's a 5. I think this is right. 6 and 9, 4 and 7, and a little X-wing to finish up. 4 and 7, 3 and 7. I hope this is right. Didn't give me a tick or anything because I haven't filled in this cell. Okay, I'm just going to check the whispers. They all seem to be genuinely difference of 5 or more. The blue line, it all adds up to 13. The thermos are good. The white dots are good. The black dots are good. The Ren bands are good. This is a 7, and that's it. The solution is correct. What a puzzle. Just under an hour. It felt like over. Felt like over an hour. 51 minutes. I'm delighted with that. I can tell you, if you have a go at Tennis Anyone, I was going to say none of the puzzles are that hard. There's one of them that's got a trick that means it might take a while, but I don't think they're at that level. Lovely, Olimar. Thank you so much. Timeout is right. It took me a long time, but I enjoyed the process, and I'm delighted to have finished. Thank you for watching. Thank you for following us on Cracking the Cryptic. We'll be back with you again tomorrow. We're relentless. See you then. Bye for now.